Okay, good day. We start our first practice exercises, and we start with a very elementary problem. And let's start and to solve the third problem from our lecture, our first lecture. Oh, I'm sorry. Problem 3. I recalled this problem. We have two villages, A and B, and road. Along this road there are village A and B. In village A are 50 students, and in village B are 100 students. The distance between villages is, for example, 3 kilometers. Question. At what point on the road should a school be built so that the total distance, sum of distances by all school children is the smallest. Smallest possible. The question: if in A and B live only one school children, there one and there one, where is this place for school should be? Maybe, and more variant. Yes, in some of the any way, any point of this way, any point. Yes, maybe this distance is x, and this distance 3 minus x. The sum of distances x plus 3 minus x is equal 3. Okay. Maybe somebody can solve this problem. What's the answer? Can you try? Okay, maybe write down.
I know I understood the question correctly, but we are trying to optimize the distance. So,
Yeah.
So it takes the minimum amount of distance to come to school with regards to amount of students. So I think if in the village A it's 50 students and here are
100 students, yes.
So and the total is 150.
Yeah.
So that means
we can suggest this point if any point by this distance x and by this distance 3 and x, and we can try minimize this sum of all distances.
To do the fraction, I
Yes.
guess. So for A it's 15 divided by 150 and it's 1/3. So for B it's 2/3. And if our distance is 3, oh, we don't even need that because we can just multiply 3 by 1/3 and we get 1, and that means we have to go to school at 1 kilometer away from B.
Oh.
Right?
No. Let's check this solution. Anyway, let's suggest the place for the school in any point P, and this distance x, and this distance 3 minus x. And let's calculate the sum of all distances. And after that, we can substitute these numbers on our answer and check is it right answer or wrong.
Should I sit down?
Yes, thank you very much. We have 100 students, and each traveled distance what is equal x, and some distances 100x. Here 50 students, and all distances 50 multiply 3 minus x. And what the sum we obtain 100x plus 150 minus 50x, and the answer is what is the x we can choose that this sum is minimal.
The minimum is 0.
0.
So
That's right.
Equal it to 0.
Yes, it's equality 0. Here, the place for the school. Let's check this answer. X is 1 kilometer, and answer in this case is equal 200 greater than 150 is not minimal distance. Okay? This is the simple example. Let's consider the more simple example. 2 students, 1 student. Let's choose 1 student from village B and 1 student from village A. The sum of distances, this x and this 3 minus x, the sum, that's A1, this distance which must traveled first student, and L2 must traveled the second children. The sum is 3 kilometers. But second students also must L2 kilometers, and in this case we can any distances L1 and L2, but we can minimize the distances of all students. We can choose equal from first villages and from second villages we can choose the equal numbers of students, and sum of these distances is also constant. But also students must choose the minimal distances. The sum of these distances is minimal if its sum is equal 0. Sum is equal 0. The most simple examples, 0 students and any numbers of students there, maybe 1. What the minimal distance here. Okay, this simplest example. Have you a question? Oh no. Okay. Yes, it's enough simple problem, but not trivial. Not trivial. Let's formulate other simple exercise. Also, the funny exercise. Exercise 4. At noon, the minute and hour hands coincided. when will they be matched next time? Next time. First question. Second, how many degrees does the minute hand turn in a minute? How hand how many degrees does the how hand turn in a minute? First question, the minute hand moves faster than how, but after one revolving, minute hand can coincide to the how hand. What just this moment when these both hands are coincide? Can you calculate this position? Oh, question. Okay. Yeah, 1 minute. Oh, I don't understand. No. Minute hand moves one turning during the 1 hour, and let x be velocity of minute hand. The all way is equal 360 degrees, and the time is 60 minutes. What is the velocity of minute hand? Oh, it's approximately yes, but only approximately. What exact moment when these hands are coincide? Approximately 1 minute, yes, exactly. It's not exactly. Can you solve? Yeah, thank you. Thank you.
I'm not saying that it will be correct. I don't know how to do the equation, but
yeah.
It feels like the minute hand goes like about how many times quicker. Well, the point is that the next hour is gonna be here,
Yeah.
and so then, well, if 1 hour passed, that means that 60 minutes
Yes.
passed.
Yes.
It's gonna come to this point, but also plus
5
5
minutes.
minutes because it needs to catch up
Uh-huh.
with this. But maybe there's a tricky part because
30 degree.
no, it's fine. I wanted to say that maybe when this 5 minutes
Yeah.
occur, our hand will move even more, but by a little bit. But
Yes. What exactly this little bit?
it will be like, so the clock is divided into 12 parts, right? So it will be
Let's try to obtain the
no, I mean,
exact
it's
equations.
12
Yeah.
30/16.
What does that number exactly?
So there are 12 parts, and it's 20.
12 parts. We can measure in degrees this the way of both hands.
But I'm trying to calculate not only 1 hour and
Yeah,
5
yeah,
minutes,
yeah.
but also but by how much will the hour mark our hand move, and it will be how much? Like that, so it cancels out, and it's 1/30, and it will be in like one part it rotates by 30 degrees, and 30 degrees is
Yes, 30 degrees.
yeah.
This angle is equal 30 degrees. Yes.
Oh, so it's just only 1 hour and 5 minutes.
Uh, 5 minutes. Yeah. Oh no, the minute hand moves. This can to solve these equations. One turning 60 minutes, and x velocity in degrees. Full turning.
Oh, I know.
And
so
our
5 minutes pass, the hour mark will move by 1/12 of
yes, 1/12. 5 minutes, 1/12, and
yeah. So it will be 1 hour 5 minutes.
5 minutes.
And also
Yes. The velocity in 5 minutes, 30 degrees. Yes, and 1 minutes 6 degrees.
that's it.
Yes, is it exact?
Okay,
Exactly.
so the answer is 65 minutes.
Approximately. But
Okay.
I would like to obtain the exact result. Exact.
So it will be plus.
After plus 5 minutes, the minute hands moves,
Yeah, I know.
and after them,
It will move by 1/12 of this.
yeah.
So it will be 1/12 of 5 minutes. So 1/12.
There is infinitely process, and we must summarize some progressions. It's very hard for me. Maybe yes, maybe. Yeah, but let's try to obtain a more simple way to solve this. Maybe. No. Maybe somebody try to solve. Can you have other suggestions for solving this problem? My suggestions. First step: let's introduce the two values x. Let x be velocity for minute hand. X is equal 6 degrees in minute. Velocity in terms of degrees. And y, let be a velocity of maybe how hand. In during of 1 hour, if y multiply on 12 hours, I obtain full revolving about original point. And y is equal 30 degrees in hour. But this values is equal half degree. In minute. And we have two values, x and y. X is velocity of degree and y the velocity of hour hand. Velocity of minute hand and y is velocity of hour hand. When the time is equal 1 hour, we have this position of both hands, and distance between these hands is equal exactly, what exactly degrees? 30 degrees. 30 degrees. Let's calculate the time when minute degrees coincide with hand degrees. Hand degrees moves and the velocity of this moving is equal y. And this way for which hand degree moving in during the time what is equal t. But hand degree for the same time must moving the way what is equal 30 degree plus x multiply t. And we have this equation. Y is equal and we have exact equation. Let's try this equation. Oh. You suggest that the moment when how hand in position 1 hour, after them is not move. It's not. It is wrong. Both hands are move, and this exact equation for to define exact value of t. Oh, I'm sorry. I'm sorry. Oh, it's not exact. Yt. Y is velocity. X. I'm sorry. S1 the way for the way for the way for the midland hand, and S2 the way for the whole hand, and this way is equal this way plus 30 degree, and is wrong equation. X multiply t is equal y multiply t plus 30. It's right. And substitute the values for velocity of midland and whole hand, and we obtain 6 multiply t is equal and is right. I'm sorry. 60 ratio 60 and 11. and 5. Less more than 5 minutes. Approximately 5 plus half minutes. That's exact answer. Okay. And we obtain the answer on the 2 question. Uh, 6 degree in minute and half degree for our hand. This exact values for velocities. Okay, this 2 easy problem and fun problem, and let's solve standard one of the standard problem. Let's given an angle A or B, and its bisector OM. So that angle COM is 1/2 the difference of COA and COB if ray OC inside is inside angle AOB. Yes, we have AOB angle and bisector OC. Let's try. Oh, I'm sorry. I'm sorry. OM is bisector. OM. And OC. OC maybe on one side of OM, but the other side. Let's suggest the point of C here, and the ray OC. The questions. COM is 1/2 difference COR minus COB. In this picture, the measure of COI is greater than COB. If position of C there, can change position COI and COB, change place A and B. It's difference COB minus COI. Let's try to solve. Have you any ideas? No. It's very standard exercises. Let's note that sum of this angle and this angle is equal one-half measure of angle AOB. And COB is equal one-half of AOB minus BOM. And this angle AOC is half plus measure of MOC or COM. And can you write these equalities and try to solve? Yeah. Oh, it's exact answer. Sunwan Gao, you are right. 60. Yeah. And Chinran Yang, yeah. Sunwan Gao, the answer for first question, 60 plus ratio 60, 11 plus 60 minutes in first. Yeah, I'm wrong. Yeah. COB. COB. No. COB is equal M OB minus COM. And AOB is equal AOM which is equal MOB plus COM, the main equation. Yeah, yeah. We have this two equations. Yeah. Oh, maybe I made mistake. COB. COB. This and this difference between this and this. A or A or B. I'm sorry. LC. I'm sorry. CO. Maybe COA. Yes. Thank you. COA. And thank you. Well, that's and let's consider the difference between this one and this one. And we have this one and this twice COM. And divided into 2, we have answer. And this assertion is proved. Okay. Let's try next simple exercise. Next simple exercise. Oh. We need to use the triangle axiom. I recall this axiom. If we have 3 points A, B, C, the distance AB less or equal the sum distances. Yeah. AC plus CB. And equalities if and only if when all 3 points collinear on one line. Okay. If A and B if we have two straight lines and this straight line are perpendicular one another, the distance between point and straight line is equal length of perpendicular segment from point A to perpendicular to straight line. The distance A or perpendicular OI less or equal distance AB for all B on straight line. And we have the following problem. Points M and n are given inside an acute angle. I'm sorry. N. Draw points K and L on the sides of this angle. So that perimeter of the quadrilateral MKL n is the smallest. We must choose the position for this point K and L such that perimeter of this quadrilateral is minimal, is the smallest. We must guess where is this position and prove that this distance is smallest. This is a more hard problem for solution. maybe we'll try to answer on the first question. Where is on the line OA? Where is on the line OA is the position of point X such that the sum distances mx and nx is minimal. Oh, yes. Yes, 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 yes.
I think that the most difference will be if we draw a straight line and put a point in the middle and draw a perpendicular line, maybe here. So the distance.
Can you prove this assertion? Why?
Okay, let me think. So in the middle and so like the distances here are equal, and if we put it on and at any point on this line A, the distances should be equal to
and why?
I don't know, it seems like when the distances are equal, it means that these are the
maybe these distances, why this sum is greater than this sum? Why? What reasons for these inequalities? You can trace where's this position, and after them to prove that is minimal distances for this position. The sum of distances is minimal. Okay. Thank you. Yes. I repeat. We want to choose such position for 2 points P and Q, such that K, L, that some distances, some of these distances, which is equal to the perimeter of this quadrilateral, is minimal. First questions. We want to choose such position for point L on straight line OA, such that the sum of the distances from M to X and from N to X is minimal. X such that Mx plus Nx is minimal. What's the idea of this? Let's try to choose so-called symmetry principle. Let's reflect this picture relatively this straight line, and we obtain such point N and such point N. Such point N. Okay. how can we use this reflected new point? Let's this point. Let's denote this point n prime and m prime. How to use? We can use. Easier to see that the distance between m prime and n prime is segment straight. I agree with this assertion. The straight line is minimal distances between any points is minimal, and this also minimal. What? What can we note in this picture? Yeah, exactly. This point is minimal. Can you prove this assertion? Why this minimal? Let's consider other point. Let's denote this point L. If L prime another point, can we prove that some distances ml prime plus L prime n greater than ml plus Ln? Can you prove? I assert that sum ml prime plus L prime n greater or equal sum m L plus Ln for any point h' on the straight line OA. Can you prove? Huh? Can you prove? Who can you prove? Let's reflect this picture. And we must note that distance m L prime and m prime L is equal, because we can reflect this triangle, one triangle on other triangle, and these distances, this one and this one, coincide, and this one coincide this one, and these distances is equal these distances. Okay, after them, these distances plus this is equal this plus this, but this plus this is equal this plus this. Such reasons. But this sum is greater this sum because 2 points on the same line, the same straight line, the smallest distances in this as a corollary of triangle axioms. Okay, we found the smallest, the position for L such that the sum of distances is smallest. I understand it. Proof. Yes. Let's continue. The second step. We found the position for L, and we can also find positions for other point K. Where is this position? let's repeat this reasoning. And what? Let's reflect this M point M2 prime and point on and we can position where is some of these distances is minimal.
It's the same, right?
Yeah, the same. The same.
Should be straightforward. So you already reflected it. Okay, where's the M? It's somewhere there. Okay, I'll put it here. So it's easier to comprehend.
Yeah.
And we draw straight line. Oh wait. Yeah.
No,
okay,
no.
everything good. No, it's actually not a good idea because it will not intersect.
Yeah.
Let's put it somewhere here maybe. Let's try. Okay.
Let's try. I repeat. New. Thank you. New figure.
The same?
The same, yes. We try to this point, so that and from this point we try to this point. Just, I'm sorry. Sorry. Maybe such that. I would like to two segments, which are smallest, which gives the smallest distances in both cases. In this case, we have such distance, and this distance is equal to this. Okay. I would like to find such position which this sum is minimal. This sum, this. Sorry. Так. Sorry. This position. This position. Yeah. This might be my mistake. This one, and I would like such okay, this and this. Okay. Yes, this position between 2 points is minimal. This, and this distance is equal this. Yes. I must to move this point K, this point L, I'm sorry, this point M, this point N, this point L, and this point K can be obtained by reflecting point of M2 prime and intersection segment N M prime with line OB is the point K, and distance MK plus KN is equal to distance M2 prime N. Okay. M N K, and this one. A. I assert that sum, and that sum is minimal sum from any point L on the straight line B, because this distance plus this is equal to this. But if I choose any other point from this line or this line, and I have any point, this sum is greater this segment, this length of this segment. And this answer, Questions? Do you understand?
Mm-hmm. Also do with n prime.
Yes, n m2 prime, n prime here. I reflect.
But why not also in the other line?
What?
Why not also n prime 2?
And prime 2, I try to prove that this distances is smallest. The main idea, the straight line between 2 points is the smallest. I choose this point so that this sum is equal the distance, the length of segment. This segment, I reflect m relatively this straight line, and I use the following observation. The sum of this segment and this, the length of this segment is equal length of this segment. And if I choose any other point, the sum of distances more than this sum. In this construction, I also can choose only one point. This construction suggests choosing of one point, but the symmetry give to our opportunity to choose symmetrically 2 points, but enough 1 point on all constructions. Okay. The main idea not I use the sum principle for maybe better understand how do you work, but main idea to prove the smallest, that the distance is the smallest.
Can I try to explain?
Oh, okay. Yes.
So you're asking why didn't he use n prime 2? Like, he didn't use m here as well. But I think that the point here is that even if you put m prime here and put a straight line here and like that, they'll intersect on this
one
line
point
anyway. So we don't even need that,
yes,
because it intersects with this line and that's
I need only 1 point. Yes.
Yeah.
Thank you very much. Oh, okay. My time is out, no? 5 minutes. Oh, okay. Yes. I try to formulate some exercise for homework. I need to some assertion. I don't to prove this assertion. This assertion is corollaries of axiom. First, if we have one straight line and 2 parallel straight line, which could this first straight line in point O prime, and maybe B, A, C. The first proposition, this angle are equal. We can use such such assertion. Also, if we have two triangles and corresponding and lengths of corresponding lengths of these triangles are equal, then triangles are congruent, are equals. Second, also we have two triangles, and if two sides of these triangles are equal and adjacent angles for this and for this triangles are also equals, the triangles are congruent. And third assertion, if one angle of one triangle are equal corresponding angle of two triangles and adjacent sides also equal, the triangles are equal. And using these principles, we must some problems I'm going to send by post these problems, and I try to solve it. Thank you very much for your attention. Thank you. Okay. Yeah, and we can answer also send by email and maybe on here. Okay, yes, I sent also Russian text by I don't know the translation. Gordon, the best, maybe one of the best books in Russian. Problems by Gordon on Russian. Exists such book, but I don't show that exists translation of this book. Yes, I sent also. Thank you.